After the second downturn, artificial intelligence became a despised sign, no longer enjoying the fascinating glory of the 1960s. However, it still achieved some initial goals, and many research results were applied in the computer technology industry. Despite various reasons leading to the departure of many, some people, driven by a certain firm belief, continue to persist. For various reasons, they fight separately in various branches of artificial intelligence, sometimes using a new name to disguise their efforts. They are more cautious than ever. Consequently, in the following 2 to 3 decades, artificial intelligence developed steadily and achieved greater success than ever before. People also learned to approach artificial intelligence more calmly. On May 11, 1997, Deep Blue defeated the reigning world chess champion, Garry Kasparov, marking a milestone in the field of artificial intelligence. In the subsequent 2 to 3 decades, artificial intelligence has continuously challenged and defeated humans in various types of intellectual competitions. Until today, in many specific domains, AI has surpassed humans by a wide margin. In 2005, a robot developed by Stanford University successfully autonomously traveled 131 miles on a desert trail, winning the top prize in the DARPA Grand Challenge. In 2011, IBM's Watson defeated human contestants on the intelligence competition show Jeopardy! In 2016, AlphaGo defeated the Go champion Lee Sedol. In May 2017, AlphaGo defeated the then world #1 Chinese Go player Qi in a 3-game match. Achieving these accomplishments is not solely due to significant breakthroughs in artificial intelligence in certain aspects, but is largely attributed to Moore's law. I am not downplaying the achievements in deep learning. Rather, the success of deep learning is facilitated by faster computers that validate various research efforts and enable breakthroughs on that foundation. Hence, the fundamental reason lies in acknowledging Moore's law and expressing gratitude to computer hardware designers and manufacturers like Intel, NVIDIA, and the TSMC. In the 1990s, scholars such as Judea Pearl and Alan Newell, building on the modular divide and conquer strategy of their predecessors, introduced concepts from decision theory and economics into artificial intelligence, forming the new paradigm of intelligent agents. They combine the idea of rational agents from economics with the concepts of objects or modules in computer science, enhancing the completeness of the intelligent agent paradigm. This paradigm allowed researchers to find probable and useful solutions by learning from isolated problems. It provided a universal language for describing problems and sharing solutions in various fields of AI, as well as areas such as economics and control theory that utilize abstract agent concepts. During this period, an increasing number of AI researchers began to develop and use sophisticated mathematical tools. Many problems addressed by artificial intelligence became research topics in mathematics, economics, and operations research. The shared mathematical language turned artificial intelligence into a more rigorous scientific discipline that could collaborate with other fields, obtain funding and support, and make research outcomes easier to evaluate and prove. Judea Pearl, in his work Probabilistic Reasoning in Intelligent Systems, Networks of Plausible Inference, published in 1988, introduced probability theory and decision theory into artificial intelligence. In the subsequent years, new tools for applications were continuously developed and put into practical use. This includes many well-known theories, methods, and algorithms, such as Bayes' network, hidden Markov models, information theory, stochastic models, and classical optimization theory. This general trend towards more formal methods in AI was described as the victory of the NEETs by Peter Norvig and Stuart Russell in 2003. Interestingly, various algorithms developed during the process of artificial intelligence research didn't contribute significantly to AI itself, but they successfully addressed many practical challenges. These algorithms garnered attention from industries and began to be applied in various domains, including data mining, industrial robotics, logistics, speech and image recognition, medical diagnosis, search engines, automation in the service industry, finance, and more. Many of these applications weren't explicitly labeled as artificial intelligence, but were given alternative names like information theory, knowledge systems, decision support, cognitive systems, etc. Some researchers chose different terminology partly because artificial intelligence had become a commonplace term and was challenging to secure funding, and partly because they viewed their research as an ordinary branch of computer science without the need for attention-grabbing names. Machine learning and deep learning are among them. Under the guise of learning, they silently advanced foundational research and continuously achieved various results. In 1989 and 1990, Yann LeCun proposed LeNet, one of the earliest convolutional neural networks. LeNet demonstrated the enormous potential of deep neural networks in realizing artificial intelligence. In 1997, Schuster and Paliwal published the bidirectional recurrent neural network. In 2006, Geoffrey Hinton introduced the deep belief network and a new layer, wise pre-training technique, marking a crucial breakthrough and initiating the deep learning movement. In 2009, Salakutinov and Hinton published the Deep Boltzmann machine. In 2012, Geoffrey Hinton proposed the dropout technique, a simple method that addressed the problem of overfitting in deep learning. In summary, during this stage, the field of artificial intelligence has developed steadily and achieved many successes, but it is far from reaching the early estimates of obtaining intelligence equal to or surpassing that of humans. While many people have cited various reasons for failures, Marvin Minsky believed it was the neglect of core issues like common sense reasoning. John McCarthy attributed it to the qualification problem. Some think it's due to limitations in computer performance, while others consider the imperfection of neural networks. Here is my perspective. Formal systems, or the symbolic approach, as described by Gödel's incompleteness theorem, has outlined its limitation. Therefore, it can, at most, serve as an auxiliary method in artificial intelligence rather than the foundational and core approach. Although I don't believe that the neural networks of humans or animals are the only way to achieve intelligence, they are currently the only effective method we have confirmed. Until we understand its operating mechanism, we cannot mimic it to achieve complete human-level intelligence. However, through continuous research, we may gradually approach this goal and improve artificial intelligence in the process. Starting from 2011, artificial intelligence entered the fast lane. Thanks again to computer hardware manufacturers, especially NVIDIA. In the last decade or so, the hottest technology in the field of artificial intelligence has been deep learning. Deep learning is not an entirely new field. It is a branch of machine learning, which is one of the routes to achieve artificial intelligence. The difference lies in its more general approach. It doesn't rely on programs to embody theorems and rules specific to a particular domain. Instead, it trains a complex mathematical model using datasets within a domain. The model learns and memorizes the knowledge in that domain. Subsequently, the model can generate or predict outputs based on unknown inputs. This is why this approach is called machine learning. It should be noted that while most machine learning algorithms are based on connectionism, not all machine learning algorithms follow this paradigm. Deep learning falls under the connectionist approach and has close ties to statistics and probability theory. Although deep learning has been around for several decades,
作业今夜平安夜，习题还有10几页，主席草习惯重习。
such as Yann LeCun, Yoshua Bengio, and Geoffrey Hinton. As mentioned earlier, their advancements in deep learning face limitations due to the lack of large complex datasets and computational
天都
power.
要晚自习，听写默写罚抄写，这道题目怎么写？哪帮丐帮斧头帮？周末还有习题班，组长班长大队长，最怕老师请家长。春分秋分贝多芬，保佑每科。
With many subcategories. Deep learning belongs to supervised algorithms and is a subset of artificial neural network algorithms. Deep learning involves multi-layered network structures, and some algorithms have network depths exceeding 150 layers, a record continually being surpassed. The mathematical mechanism behind deep learning is the universal approximation theorem, which essentially addresses how to quickly approximate any function.
只有学习让我快乐，只有知识让我爆满，只有文化让我充实，只有两学一做。
The approximation goal. However, the hierarchical structure of deep networks allows for rapid approximation while avoiding various issues associated with shallow networks. Deep learning has been so successful that numerous researchers have attempted to apply it to various problems, achieving significant progress. Researchers have invented many different network structures, studied their advantages and disadvantages, and utilized their strengths to solve specific artificial intelligence problems. Simultaneously, targeted techniques have been invented to address or mitigate many of the drawbacks of deep learning itself. State-of-the-art neural network structures can surpass or significantly exceed the average human accuracy in certain fields. For example, in computer vision, particularly in specific tasks such as handwritten digit recognition, traffic signal recognition, chess competitions, and gaming. Deep learning models have surpassed, and even far surpassed, human performance. Alongside the development of deep learning is the advent of big data. Big data refers to a collection or set of information assets that are large, growing rapidly, and diverse, making them difficult to be captured, managed, and processed by traditional software tools within a certain time frame. Big data is characterized by massive data scale, rapid data flow, diverse data types, and low value density. New processing models are needed with enhanced decision-making, insight discovery, and process optimization capabilities to adapt to and handle big data effectively. The development of big data and deep learning is mutually reinforcing. On the one hand, deep learning requires vast datasets for training models, and on the other hand, the application of deep learning to big data analytics has accomplished analyses that were previously impossible. With the development of machine learning and deep learning, another machine learning approach, reinforcement learning, RL has re-entered the researcher's focus, rapidly evolving and merging with deep learning to form deep reinforcement learning. Reinforcement learning is distinct from supervised learning and unsupervised learning, representing a third learning paradigm. One of the drawbacks of deep learning is the need for a large amount of labeled data to train models, requiring significant effort to handle extensive datasets. The scale and quality of datasets have a direct and substantial impact on the accuracy of the model. In a sense, relying solely on deep learning methods will never create true artificial intelligence. Comparing humans and animals, aside from some basic instincts derived from genetics, most of our intelligence is acquired through learning in the environment. The fundamental difference between reinforcement learning and deep learning is that reinforcement learning involves learning the mapping from the environment to behavior, using limited reward signals from external feedback to learn. Due to the limited external signals, reinforcement learning systems must rely on their own experiences for self-learning and adapt their strategies to the environment. The three key factors in reinforcement learning are states actions and environmental rewards. One of the most notable achievements of reinforcement learning is AlphaZero's victory over AlphaGo. AlphaGo, based on deep learning and partially reinforced learning, needed to learn from evaluated games of human players belonging to supervised learning. In contrast, AlphaZero's training was entirely based on self-play and reinforcement learning, without guidance from any human Go player, and without instilling any form of Go skills. Reinforcement learning demonstrated that artificial intelligence can acquire various intelligent capabilities through self-learning in an environment without prior knowledge. This marks another profound advancement after deep learning. Today, AI based on reinforcement learning can almost defeat top human players in various open-ended games through rapid self-learning.
In the 1970s and the 1980s,
the development of learning theories laid the foundation for reinforcement learning. Richard Sutton, a renowned pioneer in reinforcement learning, and Christopher Watkins, among others, introduced fundamental methods such as adaptive dynamic programming and Q-learning. In the 1990s and 2000s, Christopher Watkins proposed Q-learning algorithms based on differential learning, considered a significant milestone in modern reinforcement learning. After 2010, with the introduction of deep neural networks, reinforcement learning experienced substantial advancements and breakthroughs. Deep reinforcement learning has achieved astonishing achievements to this day, based on the latest artificial intelligence technologies such as deep learning and reinforcement learning. Some remarkable achievements have emerged, rapidly reaching the hands of the general public and exerting a profound impact on human society, culture, and civilization. Artificial intelligence is beginning to demonstrate its remarkable influence, both exhilarating and at times unsettling. Current speech synthesis technology can produce highly realistic results, and speech recognition has entered practical usage. With sufficient resources, individuals can train models to recognize any language worldwide. These technologies are already extensively used in various electronic products in daily life. Generative artificial intelligence is becoming increasingly mature in large language models and visual generation. New products in these areas are introduced almost every month, continually pushing the boundaries of generated quality and convenience, consistently exceeding people's expectations for artificial intelligence. Large language models can engage in conversations, much like humans, and offer a variety of consultations. They surpass any previous artificial intelligence models in comprehending the true meaning of human language within its environment and context. As a result, they can serve as a higher-level search engine, going beyond the simple listing of results typical of traditional search engines. Instead, they can integrate relevant content from their learned knowledge to provide users with information aligned with their search objectives. These models also function as advanced machine translation systems, facilitating seamless translation between many languages. They can act as sophisticated programmers, generating required code based on user requests. Additionally, they excel as authors, crafting interesting stories, poems, and even academic papers based on given prompts. In the realm of visual generation, various tools for image and video creation continue to emerge, profoundly impacting fields such as social media, video production, media, and filmmaking. All these amazing achievements are beginning to have a profound impact on various industries and the entire fabric of societal life. Personally, I believe it may trigger a social revolution akin to the agricultural revolution, industrial revolution, and information revolution that humanity has experienced. Many people are starting to reconsider the future of humanity, with more individuals facing the possibility of unemployment due to being replaced by artificial intelligence. The entire society is continuously being touched and influenced by these developments. Currently, people are raising a series of questions, including whether artificial intelligence will replace their jobs, and if it could potentially replace the entire human race. Some scientists have made predictions suggesting that humans might serve as a pathway to more advanced artificial intelligence and may eventually be replaced. These profound discussions will be explored further in upcoming videos.